So the topic assigned to me is the cubic spline interpolation. So let me read what is the definition of this topic. A cubic spline is a type of spline interpolation where every curve connecting two consecutive points is a cubic function. For data with n plus 1 pairs of points, n spline functions are needed. So here are the cubic splines. So for the first interval, which is x is greater than or equal to x sub 0 but less than or equal to x sub 1, here is y is equal to a sub 1 x cubed plus b sub 1 x squared plus c sub 1 x plus d sub 1. For the second interval, for which is x is greater than or equal to x sub 1 but less than or equal to x sub 2, y is equal to a sub 2x cubed plus b sub 2x squared plus c sub 2x plus d sub 2, and so on and so forth. Y is equal to a sub n x cubed plus b sub n x squared plus c sub n x plus d sub n for the interval of x is greater than or equal to x sub n minus 1 but less than or equal to x sub n. Since there are four unknowns which are a sub 1, b sub 1, c sub 1, and d sub 1, so there is a need of 4n linear equations to solve for these unknowns. These linear equations are derived in the following steps. So there are 4 steps to derive a linear equations. First is all given points are parts of the spline function. There is a total of 2n linear equations derived on this step. The second step is the first derivatives of two splines sharing an intermediate point are equal. So there is a total of n minus 1 linear equations derived on this step. The third step is the second derivatives of two splines sharing an intermediate point are equal. There is a total of n minus 1 linear equations derived on this step. The second step and the third step is they have the same linear equations to be derived. The fourth step is the second derivative of the first and last spline functions is assumed to be 0. So there is a total of 2 linear equations derived on this step. There's a roll. Thank you.
Next, let's talk about alternative method for cubic spline interpolation. It is a more simplified way of obtaining the cubic spline function for every two consecutive point. Mauni siya ang formula. Kanang mga x sabay, usually given na sila og ang unknown nga ato lang kailangan pangitaon kay ang second derivatives. As what I've said, the only unknown on the mentioned equations are the second derivatives. This can be solved using a linear system derived from the formula below. Complicated siya tan-awon, but once we apply it to an example, mas masabtan na ni siya. Ang goal ani kay ang makakita tag linear system kay mao man ang gamiton para mahibaw-an ang second derivatives. Note that the second derivative at the endpoints of the curve is equal to 0. So di ba mausad ni siyang step 4 sa cubic spline. Ang second derivative sa x sub 0 of x sub n kay equals to 0. Unlike the conventional method of cubic spline interpolation, where there is a need to solve 4n linear equations for n plus 1 pairs of data, this method needs to solve n minus 1 equations, making it easier to solve both by hand and by computers. So mas dali ni kay gamay rang linear equations nga i-solve ug mas dali siya by hand. Sa traditional spline, ang kailangan i-solve kay 12 equations. And for the alternative method is 2 equations only. Ang concern lang ani kay ang second derivative. So example, na ay 4 points given, so na ay f double prime of x sub 0 to f double prime x sub 3, Unya ang isig tumoy nga second derivatives kay 0 which is noted above. So ang f double prime x sub 1 ug f double prime x sub 2 na lang ang unknowns. Maunang mahog nga duha na lang ka equation ang angay isolve.
And for the quadratic spline interpolation, what is quadratic spline interpolation? Is a type of spline interpolation where every curve connecting two consecutive points is a quadratic function. Thus, for data with n plus 1 pairs of points, n spline function are needed. These quadratic equations are y equals a sub 1 x squared plus b sub 1 x plus c sub 1. So, yung range is from x sub 0 to x sub 1. Next is y equals a sub 2x squared plus b sub 2x plus c sub 2. Ang yang range which is x sub 1 to x sub 2. Last is y equals a sub n x squared plus b sub n x plus c sub n. So yang range which is x sub n minus 1 to x sub n. So, and for every equation, there is three unknown, which is a sub I, b sub I, c sub I. Thus, there is a need of three linear equation to solve for this unknown. This linear equation is derived of the following. So, kung pila iyang equation, just multiply it by 3. So, 3 man siya diri. So, times 3 mo which is 9. So, how to find those equation? First is all given points are parts of this spline function. So in that case, there is a total of two linear equation derived on these steps. And second is the first derivatives of two splines sharing intermediate point are equal. There is a total of n minus 1 linear equation derived on this step. So ang first which is 2n, ang second which is n minus 1. And the third is the second derivative of the first spline is assumed to be 0. So there is only one equation derived on this one step, and that is 2a equals 0. Because of that assumption of first spline is actually line. So ang sa first natay 2n, nya ang second natay n minus 1, and the third is 1 equation. So imo siyang i-add tanan, and ang makuha na to which is 3n. And that's all. Thank you.
Good day everyone, I'm Jamaica Pacquiao from Group 3 and the next topic is curve fitting by function approximation. Curve fitting is a process of finding the equation of the curve which best fits the given values and is most suitable for predicting unknown values. So it is also a process of constructing a curve or mathematical function. Next is function approximation. Function approximation is anything that is similar but not exactly to something else. It is also known as function approximation problem. Is asked us to select a function among a well-defined class that closely matches a target function in a task-specific way. So, the goal would be to come up with an approximating functional form using a finite set of data points. So as you can see, there are two pictures. So these are the examples of engineering applications. So next, the regression and interpolation. So curve in curve fitting. So there are three curve fitting, regression, and interpolation, which is least squares, regression, linear interpolation, and curvilinear interpolation. So first is the least square regression, is the line that makes the vertical distance from data points to the regression line as small as possible. It is also called a least square because the best line of fit is one that minimizes the variance, or the sum of square of the error. So next is linear interpolation. So the method of curve fitting using linear polynomials to construct new data points within the range of discrete set of known data points. So next is curvilinear interpolation. So these three um, curve fitting um, examples or regression and interpolations are very important to this topic. So next slide.
Good day everyone. So I was assigned to discuss about least squares fit. So let us define first the least squares fit. The least squares method provides the overall rationale for the placement of the line of the best fit among the data points being studied. An analyst using the least squares method will generate a line of best fit that explains the potential relationship between independent and dependent variables. So the dependent variables are illustrated on the vertical y-axis, while the independent variables are illustrated on the horizontal x-axis. These designations will form the equation of the line of best fit, which is determined from the least squares fit method. Next slides. So for better accuracy, let's see how to calculate linear least squares regression. So sa kaniya sa curve fitting, ang ato abuhaton ani is mag-solve ta for curve fitting or linear equation fitting data in the form y equals a sub 1x plus a sub o. So for a given set of n data points, which is x sub I and y sub I, the overall error is calculated at the formula shown below. So the overall error should be the least error that we can get. So and also in getting the A1 and AO, the formula is being shown. So kana sa SX gali mao nang summation sa or total sa tanang x values. Sa SY simply the summation of all y values. Sa SXY summation of the product x and y. Katuang gimultiply na ito nga mag-partner sa x o sa fx or sa y. Then sa sxx, the summation of squares of all x values. So we have here an example for linear least squares regression. According to Church's law, for an ideal gas at constant volume, a linear relationship exists between the pressure P and the temperature T. In the experiment shown in the figure, a fixed volume of gas is then increased and submerged in ice water. T is equals to 0 degrees Celsius. The temperature of the gas is then increased in 10 increments up to T equals 100 degrees Celsius by heating the water. And the pressure of the gas is measured at its temperature. The data from the experiment is, so kung ato niyang tanawon ang table, mo niyang 10 increments nga nagkasaka siya by 10. So that is 0, 10, 20, 30, 40, kutub, 100. Whereas in its temperature, the pressure is also measured in terms of atmosphere. And then the question is, Use linear least squares regression to determine a linear function in the form P is equals to A1 T plus AO that best fits the data points. Calculate the coefficients by hand using only the 4 data points, 0, 30, 70, and 100 degrees Celsius. So, kung ato ni graph guys, mao ni ang naong o mugawas. Kung ato siyang tanawon o dili siya or we cannot connect it using a line. That's why we will do curve fitting. So, by using that, mana na tayo equation that best describe the set of data. The step 1 would be get the coordinates of the data points. So, the temperature would be the x and the pressure is our y component. So, we only two concerns with 0, 30, 70, and 100 degrees Celsius. Taking those down, we know nga ang 0 is ang x, ang 0.94 is ang y, ang 30 is ang x, ang 1.05 is ang y, and respectively. This coordinate should be in partnership for us to get the best fit curve. The next step or the second step would be to determine the value of Sx, Sxx, Sxy, and Sy. Kining Sx guys, mao ni ang summation of all x values. So, ang total sa x values nato. Mao to ang 0 plus 30 plus 70 plus 100 equals 200. While for the Sxx, it is simply the summation of the square of all x values. So we have 158,000. While for the Sxy, this is the summation of the product of x and y. Ni ang total sa gi-times nato nga duha nga magpartner kato ang x ug ang y mao nang ni come up ta og answer nga 241.1. And lastly, for the Sy, this is simply the summation of all y values. So katong y values nato tanan, total niya mao ni ang 0.94 plus 1.05 plus 1 plus 1.17 plus 1.28 equals 4.44. Karon, kahibaw naman ta sa values respective sum parameters, we can now directly substitute it by the formula of A1 and AO nga kanina sa babaw sa step 3. When we substitute it, the value of our A1, kung ato na ni silang i-substitute, ang value sa atong A1, we have is equals to 0.003345. Ug ang AO is equals to 0.9428. Now, knowing this, in step number 4, simply substitute A sub 1 equals 0.003345 and A sub 0 equals 0.9428 to the linear equation form P equals A sub 1t plus A sub 0. So the equation that best fits the data is been defined by P equals 0.003345t plus 0.9428. We can get what is the equation of the best fit linear sa atong data nga naka-present. That's all, everyone. This is the end of our presentation.